don't want to spend too much money? Well, I have the perfect option for you. My name is Ellie Heyer, and I am the PR officer for NHS. I am here to tell you all that your senior shirts are back on sale. You can order through a QR code that is posted around the school or through the link. The link will be emailed to you and your parents or can be found on the NHS Instagram page. I hope you all have a great day and get to buy. Go Bolts!
All right. We have today until 11:24. Let's go ahead and look at what we're going to be doing. Students' objectives. You will be able to identify the role that plate boundaries play in earthquakes and determine how humans can reduce the destructive impact of very unpredictable earthquakes. How are you going to do that today? Students are going to watch a documentary, take notes, and apply previous knowledge. Our question of the day on our agenda, it says, what do you think is the correlation, meaning connection, between underlying geology of a location and the earthquake damage in that location? I want to let you know after our capture question, we're going to go ahead and talk about registration. We're going to get our notebooks out, our Chromebooks, and we're going to register for science next year. And then we're going to watch a video on Deadliest Earthquakes today and finish it tomorrow. If you are wanting to still retake that plate boundary quiz, please come in today during Liberty time. And I want to let you know you're going to have a volcano quiz tomorrow. I just wrote it. I think it's super fair. There's a little kind of like one sentence answer, then there's some multiple choice, and then there's matching. So it's 4 points. Are you focused on me or your cute little like blanket?
No, we were talking about this room.
All right, so what I'm going to do is I'm going to be quiet for about 35 seconds, 40 seconds to allow you to go ahead and write this down and get out yesterday's, put your phone away, get out yesterday's assignment because the back part of it is what this is. So get out yesterday's assignment. We are looking at the back page of yesterday, so you will need this. Get this out. Get this out. Get this out.
What's that?
From yesterday. Get this out.
Get it out.
Get it out. That's going to help us with our discussion today. All right. You be quiet. I'm going to go ahead and take attendance, and then we will start reviewing a little bit from yesterday before we move on. Kendall, we are getting out yesterday's paper on the back, our Digging Deeper section. It was from Friday. You were here Friday. All right, let's go ahead and look at what we've got here. With your pair share partners, if you could please turn and talk and share out, what do you think the correlation, meaning the connection between underlying geology and earthquake damage? You will need to look at this picture to help you out. Logan, put away your mask. So if you look at this picture in your explanation of what do you think the connection is between what you build on and the damage that's going to occur in your area. And your time starts now. Turn and talk that out. Go.
I don't know. What do you ask us to do? I actually need to come back, that kind of stuff, and get it
Great,
right.
yeah,
It's just kind of rude to work on another class.
I know, but I can use this.
I know you can, but.
Obviously not you.
All right, my dears. If you had the opportunity to live in San Francisco on the Bay and you had an apartment building at location X, apartment building at location Y, apartment building at location Z, which one would you want to live in an apartment? Why X?
Because it's the most stable ground.
It's the most stable ground. Why is it? Good question. It's not more flat. They're all flat.
It's like, more,
Compact, yeah, the material is. So X has sandstone that all of the buildings are built on. And this is what sandstone is. It's very compacted sand that's been compacted over billions of years. And it's solid, okay? So I can't stick my hand through that. It's got a very high density if you want to think about it that way. And so when we're looking at the geology, this letter Z is artificial fill. So if you were not here yesterday, go to the back of this piece of paper and you want to be filling in what each one of these locations seismometers. A seismometer is a machine that records earthquake waves, where each of these seismometers are located at. On the bay right here, this X is located on sandstone. That's what this is. It's solid bedrock. Z is on artificial fill. That means that this was at one time all water, and they said, you know what? We want to put more buildings on the bay. So we're going to go ahead and break up concrete, put it in with a whole bunch of fill and debris, and fill it in, and then we're going to build on it. It's not very solid. This, Y, is beach and sand dunes. That's what that is. And so again, they're building on top of that geology. Now, these are seismographs or seismograms. This is the information as an earthquake goes through. We're looking at the amplitude of the wave. Amplitude is the point up and then down from that middle area. Which of these locations has the lowest amplitude of energy? X. If I live there, am I going to be affected by the earthquake? Yes. But am I going to have as much damage as if I'm in location Y or Z? Why?
because it's more compact.
Yeah, because the earth is not going to be moving as much. Imagine if the land below you turns to jello, and you're trying to stand up, and everything's trying to stand up, and the building's trying to stand up, and then you've got liquefaction to deal with. Did anybody read about liquefaction? Yeah, do you remember what liquefaction is?
It is earthquakes causing mud or dirt and water to combine basically and turn into.
Yeah, it's basically like the land that your building is on turns into quicksand. And so what's happening is, if you imagine that you're all little dirt particles and there's a water molecule in between all of you, you're separated by water in the ground. And if I shake you and move all of you next to each other, the water that was between each particle has nowhere to go but up. And it starts to make a soupy kind of mixture on the ground, and you just kind of like the foundations of the buildings are no longer supported. Liquefaction is no joke. I'll try to find a little video on that. So if we are looking here with our question, and what was the original question? Does anybody remember how it was said? What do you think is the correlation between underlying geology? Okay, so if the material, Billy, if you wouldn't mind turning that if you already haven't, if the material is blank, then there will be blank damage to the buildings. So with your pear-shaped partners, talk that out. If the material is more dense, less dense, then there will be more or less damage to the buildings. Turn and talk that out and fill in, please, the missing parts of this sentence. On your marks, get set, go. After you're done with that, I need you to get out your Chromebooks.
Yeah.
When you get out your Chromebooks, please go to Infinite Campus.
Okay, y'all can turn the camera back. They can't see you.
Why do you think they would put more land in the bay? More money. Living in San Francisco Bay? Imagine how expensive that would be. Beautiful location. Has anyone mind turning it back this way, my dear? All right, you are gonna go to Infinite Campus, my darlings. You're gonna go to Infinite Campus, and I am going to show you something about registration. I'm not gonna go through all of them, but I do wanna show you the pathway that you are going to want to take. All right, that shut off. There we go. So normal pathway, and there's no such thing as normal because we don't really have, if you like are in Earth and Space right now and you want to skip biology and go right to chemistry, and then when you're in 11th grade, if you want to go back and take biology, you can. As long as you have the math requirement for chemistry, which is Algebra 1, you can go ahead and take chemistry next year if you want. Most people go Earth and Space, biology, chemistry, and then physics their senior year. If you don't have the math requirement to take chemistry, then what you'll do is go Earth and Space, biology next year, physical science 11th year, and then you can go back and take chemistry if you want when you're a senior, or you can take physics when you're a senior, as your math catches up with you. Question?
Can you take both?
Absolutely. If you want to go ahead and take 2 classes at a time, how many of you right now are taking 2 science classes at a time? Yeah. So right now Logan's taking Earth and Space Science and Biology. Because he's taking biology right now, we're going to push him into not regular chemistry, but honors chemistry. Now, here's my deal on that. I don't think anybody should be pushed any which way. Honors chemistry is moving at a faster pace, and it's going to go much deeper than your regular chemistry. But that doesn't mean that if you take regular chemistry, you're going to be unprepared for college. You're going to be prepared for college. You're going to live a perfectly productive, wonderful life by taking chemistry. The people here are going to be like preparing you for college. This would be if somebody is on a faster path for whatever reason in their life, if they want to be a doctor, if they want to go into something, and they are just being pushed to accelerate, this would be a way to accelerate. That's it. But you don't have to do that. In this district, unfortunately, it seems like we want everybody to just take upper classes faster and faster. You don't need to do that. So everybody in here will be taking probably biology unless you've already taken biology. How many of you have already taken biology? Because some of my 9th graders came from other districts and they took biology last year, and so I've got 10th graders taking Earth and Space this year. Okay, good. So most of you, you're going to sign up for biology. Unless you're in biology like Logan, you're going to decide if you're going to take chemistry next year or honors chem. If you want to go ahead and take biology and chemistry next year, absolutely you can do that. If you want, if you have the math requirement, you can do that.
Can I take 3?
No, I would not do that. Now, if you want to go ahead and take an elective science, like maybe a computer science, an intro to engineer design science, something like that, you could do something like that, but I wouldn't take 3 of your, like, are you thinking biology, chemistry, and physics next year? No. I'm just saying, why? No, you won't even have room. You're not going to probably have room in your schedule for that anyway. Yeah.
So if I take biology
Yep.
next year, am I able to take honors chemistry? the year after?
No, if you're taking biology next year, oh, you mean can you take honors chemistry?
The year after.
If you want.
Okay.
Yeah, you can. You can definitely do that. If you want to take biology next year, then the year after that, you can either go honors chemistry, or if you want to go AP biology, you can. You cannot take AP biology until you've taken biology.
Okay.
And then, of course, there's AP environmental science, which is like all about the, earth, pollution, all that. Really interesting class. A lot of people like it. So what you are doing right now is you should be in your...
Well, teachers should have a family consumer. And then on Wednesday, the Infinite Campus, and we appreciate until academic planning day.
You should be here. You should go into Infinite Campus and be at your academic plan. Hit enter. Once you are in your academic plan, then it's going to ask you some questions about what is your post, blah, blah, blah. Just go to proceed. Go past that and go to proceed. And then you should get here. Let me know if anybody is not here. Or you need help getting here. Are we good? When you're here, notice that this is grade 9 for you. You're done with that. You are gonna go ahead and look for the grade 10 column. And this is English classes. You need to scroll down, please, until you find science. And then when you find science in this little area, go ahead and type biology or chemistry or honors chem, whatever it is that you are taking. Now, for those of you that want to take 2 classes, I don't know how to do that in this. You probably are going to have to talk to your counselor about adding that extra science in. Yep.
Can you take biology and chemistry honors the same year? Or do you have to take biology first?
They want you to, I don't think, good question, sign up for it. See what they do. If you start out at honors chemistry, what is wrong with saying, wow, this is not my speed? I'm going to transfer into a regular chemistry class. Who cares about that? Who said McGrain? Yeah. You can't do physics.
15 credits from.
Yeah. Actually, I don't know. Sign up for it. See what they do. And it's not letting you.
We had German. Like, nobody does fucking German.
Oh yeah. Are you in the right? I think this is your column. So like if we go up here, this is grade 11. You need to be grade 10.
First I would myself do that.
Please make sure that you are in grade 10.
I just want to go on that trip.
Yep. Make sure that you're in grade 10 and you're doing a search on, yep, you're getting bio.
Wait, you do things first too?
Yep. And then I think you need to go into, can I just go here? I think you need to then go, oh yeah, he's grade 9.
That's fucked up.
Yeah, you're good.
I'm gonna just 2 weeks.
Yeah. Yep.
Girl, you're tripping. Just skip a whole Spanish class.
When you're done at the very top, it says save. Please save. Biology.
No, it's not gonna say zero.
And then at the very tippity top, hit save. Don't forget to hit save. It'll come up with an error message. You just say okay.
Okay.
Hit save. Yeah, honey. I will try.
Can you do my survey?
Oh, send it to me. I can't do it right now.
That's fine.
Billy, what's up? It'll come up with an error message and just say okay.
You wanna do my email? I mean my survey?
Look on the side there, it says be sure to say save. There may get an error message, but that's okay.
Thank you.
Have you gotten in and out of Infinite Campus?
How you spell your name?
If you're Infinite Campus, you did not log out from first hour to this hour, then you'll need to redo it. You'll have to reboot.
You're not doing it. Y'all go make
Close Infinite Campus and get back into it. If you have not closed Infinite Campus, you need to close it and then come back in.
I don't like
Yeah,
it.
yes.
I need to.
They have been working all second hour to make adjustments to the system. So if this is Infinite Campus that you have had open, you'll want to close it and then log back into Infinite Campus if you have not done that. You did that? So by now, you should have had first hour if you had a class there, second hour if you had a class there, and then third hour. Next hour, whatever class you have there, they'll go through this process.
Who's taking the personal?
And then don't worry about your electives. They're gonna go ahead and do electives in a little bit.
Where? I'll let you where?
They're going to, I think, next advisory, next week, you're gonna go and sign up for all your electives.
I already did my
Great? All right, if you could please shut that, I would greatly appreciate it. We are gonna go ahead and watch a movie, and the movie is called Deadliest Earthquakes.
We gotta take notes. Wait.
You do, you picked up a note sheet on the way in.
We have to do world history.
Yeah.
You have to take an English elective. You have to take English elective? I thought that's if you didn't take
Okay,
it.
then you need to definitely mark that, you gotta go talk to your
Oh,
counselor
no,
about
you're talking
that.
about, oh, it's elective.
For sure, 100%, and then they'll fix it. They should have that on record, but apparently they don't.
Right, real good. I only have 7 out of
Please,
9.
Says that I took
7 out of
there you go, please make sure that they're finding lots of little hiccups. Make sure you write a note to yourself to talk to your counselor.
It'll give you extra credit.
All right, honeys.
I'll just take another elective.
I'll make an appointment with her.
And then I have to do a
In
lot of
Haiti, over 200,000 people are killed. Weeks later, cities half a world away in Chile are leveled. 500,000 buildings damaged. Around the globe, millions live above active earthquake zones. What causes these
Anything
earthquakes?
you want at this time.
And why are the subterranean tremors so hard to predict?
We can't see earthquakes coming, that's the problem. 1 minute they're not there, the next minute, wham.
Now, the race is on to find ways to warn us of impending disaster. And science is revealing new insights into what is actually going on beneath the surface.
It tells us something about the way plates slide past each other that we had no clue about before.
But the clock is ticking. And the next one could be in our own backyard.
This is earthquake country. We don't know when that earthquake or sequence of earthquakes will occur, but they're inevitable.
The earth-shattering truth behind the deadliest earthquakes. Up next on Nova.
If anyone has 2-liter bottles at home, like empty 2-liter bottles, I'll take them. We need them for next unit.
Major funding for NOVA is provided by the following: David H. Koch and
Discovering New Knowledge. HHMI.
Make sure
and
you have
by
your sheet out,
the
please.
Corporation for Public Broadcasting, and by contributions to your PBS station from viewers like you. Thank you.
Jose, did you hit save?
Yeah.
Port-au-Prince, Haiti. January 12th, 2010. 4:53 p.m.
Thank God this was 4 o'clock in the afternoon. Imagine if it was like 1 o'clock in the morning and everybody was in bed.
Baby, the water's coming to an end.
It was really, really bad.
The city is hit by the Western Hemisphere's deadliest earthquake in a century. This busy metropolis is reduced to rubble in less than a minute. 233,000 people lie dead.
That's a lot of
Millions more are injured or orphaned. As 2010 unfolds, more earthquakes strike around the world. Each time there is no warning, and often massive loss of life. Scientists are working around the clock to unlock the mysteries of earthquake prediction. Within days of the Haiti catastrophe, Professor Eric Calais, a seismologist from Purdue University, arrives on the island. Calais and his colleagues are at the cutting edge of earthquake research. They could see this disaster coming. They've known for years that a Haitian earthquake was inevitable.
So that gives you a clue there. How
Today,
did
Calais
scientists
is
know
leading
that
a
an
rapid
earthquake
response
was
mission
inevitable?
to find out exactly what happened and to assess the risk of more quakes. For nearly a decade, he's used GPS markers scattered throughout Haiti to monitor the ground shifting under the island.
Use GPS markers.
We're headed to a place where we have what we call a benchmark. We have a precise position for that benchmark before the earthquake, and now we're going to measure its position after the earthquake.
Motion.
Many
They saw
markers
the
are placed
tension
in
and stress
well-built
building
police
up.
stations. Embedded in solid concrete roofs, they survive the earthquake.
The benchmark that I was talking about is this. It's not spectacular at all. It's a piece of metal, stainless steel, that we sealed at the top of this building. And there's a little dimple that's about 1 millimeter wide. And this is the point we've been tracking over time. Since 2003, the first time we measured this point.
Calais' GPS measurements reveal telltale
this
movements of the Earth.
We'll send a signal up to a satellite and come down, and they'll see how much the land is moving.
Over a decade, the satellites tracked the ground south of Port-au-Prince creeping east, and the ground north of the city creeping west at fractions of an inch a year.
Okay, so here's my question for you on number 2. If half of the country's moving east and half of the country's moving west, what type of boundary caused the Haitian earthquake? Transform boundary. Transform boundary. Transform boundary. One's moving in one direction, one's moving in the other direction. The whole island is separated by a transform fault. Oops.
Then, during the quake, a huge slippage takes place.
So that's how the island
This
moved.
location here moved by about 30 centimeters during the earthquake. So this is 30 centimeters more or less, something like that. So this whole area here has moved 30 centimeters to the east during that earthquake.
These movements are a clue to what happened underground. The Earth ruptured nearly a foot along a hidden fault line. Most earthquakes originate in deep fractures in the crust, miles beneath the surface. These giant fractures crisscross the globe, splitting the planet's 50-mile thick crust into around a dozen huge rocky slabs.
The Earth is enclosed in a rigid shell, if you like, and this shell is made up of different plates, rigid rocky plates, which move around at about the same speed as your fingernails grow. There's this sort of dance of the plates going on all the time around the planet's surface.
Geologists call this dance plate tectonics. The planet's internal heat moves the huge plates. Above the hottest zones, molten rock rises and solidifies, creating new crust. The new crust jostles for space, forcing crust on cooler edges to grind against other plates or push beneath them. But wherever or however plates collide, they generate earthquakes.
Earthquakes happen because these huge chunks of rock that form the Earth's plates don't slide against one another nice and smoothly. They stick and they lock. So you're getting this enormous accumulation of strain, and then you're getting it released in a matter of seconds during the earthquake.
And
The
that's how
quakes
the
can
land
originate
moves.
tens of miles down, but the energy they generate creates deadly vibrations on the surface.
The amount of energy generated in the biggest earthquakes are comparable to many, many thousands of nuclear bombs going off. There's a huge amount of energy, absolutely vast.
Haiti lies directly above a network of massive faults,
So number
where the
3,
Caribbean plate meets
thousands
the North
of
American plate.
nuclear bombs.
As the plates slowly creep past one another, the rock distorts and stretches like rubber, building up enormous stress. Since 2000 fleet creep past one another,
So here's what I want you to know. This part goes in this direction, this part goes in this direction. And the plate is moving, but here it's locked in place and not moving. So it's like distorting. This part is moving forward, this is not moved. This part is moving backwards, this part is not moved. And so all of a sudden it like slips, and this part catches up with what's been going on over here, and this part catches up with what's been going on here, and it moves really quickly. That's what an earthquake is. It just gets stuck, locked in place, and then all of a sudden, whoop, it moves.
The rock distorts and stretches like rubber, building up enormous stress. Since 2003, Calais and his colleagues used ground movement data to calculate stress levels at the plate boundary. Calais realized a deadly quake was inevitable.
What we saw was a fault being loaded, just like a rubber band.
Simple math allowed him to calculate the precise elastic strain on the fault.
The last earthquake on that fault occurred about 250 years ago, and it's building up elastic energy at 7 millimeters per year.
7 millimeters per
7
year.
times
It should be
250
moving.
is about
It hasn't moved for
1.8 meters.
250 million years. It's a long
That's
time.
almost 6 feet of stored strain, equivalent to 100 Hiroshima atom bombs.
But this one only moved a foot. So what does that mean?
Seismologists use a logarithmic scale to
There's
measure
more still
earthquake
built
strength.
up in there that hasn't been released.
Each number indicates a seismic wave 10 times larger than the number below. A 2 is insignificant, but a 7 or above can be immensely destructive.
Here's what I want you to know. The energy
In
released
2008,
between a 2
Calais
and an
announced the
8
Haitian fault could generate an earthquake above magnitude 7.
equals
2 years later,
1
his forecast proves accurate.
billion.
Breaking news from Haiti tonight, where a massive 7.0 earthquake
billion
measured at
units of energy.
7.0 history has crippled the country, measuring 7.0.
That's
Calais
number
came
4.
closer than
So the energy released between it's like a billion times more strong than a 2.0 earthquake. That's like crazy amounts of energy that is being released. So it's not just like, oh yeah, it was a 5 point, or oh yeah, it was a 6 point. No, it's like magnitudes of huge numbers that get this increasing.
anyone to giving an accurate warning of the quake. But like all seismologists, he had no idea exactly when it would happen.
We cannot predict earthquakes. We
Billy,
had no
could you
way of
turn it
telling
this way for a
whether it
second
was
so
going
we
to be
can read
today,
the board?
tomorrow, in 10 years, in 100 years. So we didn't put a date on it.
Thanks, you
And
can turn it back.
it's not that we were afraid to put a date on it. As a scientist, we can't.
Today, seismologists can calculate the pressures on the plate boundaries. But they can't predict when the faults will rupture.
You just don't know when it's going to break
earthquakes
and
coming.
release.
That's the problem. 1 minute they're not there, the next minute, wham.
Back in the lab, Calais now attempts to find out how much stress remains in the Haiti fault. It's bad news.
We saw on January 12th that only a small portion of the fault actually ruptured. The fault itself, from the Dominican Republic all the way to the western end of the southern peninsula of Haiti, is about 300 kilometers long. And it's only a segment of 50 kilometers in the middle that released its energy during the earthquake.
The rest of the fault remains under stress.
So the
Calais
stress just
predicts that
built
segments
up
even
down the
closer to
line.
Port-au-Prince could snap at any time.
Those segments have been brought slightly closer to the next earthquake. Again, what's the timeline? We don't know.
Port-au-Prince is not alone in its predicament. Anywhere on the globe above an active fault is vulnerable. And the faster the underlying plates move, the more frequent the quakes.
That's number
The
5.
Middle East, South Asia, China, the Pacific Rim. In the absence of prediction, these zones remain some of the world.
So number 5 says the faster the movement of the plates, the more frequent of the earthquakes. Was that true or false? That was true, and you found that hopefully also by looking at your map from Friday and on Monday. when we saw those plates that had a longer arrow at the end in the direction they were moving, they were going to have much more frequent earthquakes. Because as it's moving forward, right, it's just, you can't help but have more earthquakes, especially if something's jamming itself underneath another plate.
World's deadliest places. And let's not forget California,
Okay, so
home
now we're on the
to
second
the San
area.
Andreas Fault.
So it says, what is the name of the main fault that we have in California? San Andreas. They just said it. 6 is San Andre. I think I spelled that wrong. Let's see if we can figure out what kind of a fault that is, what kind of a boundary that is. Do we know what kind of a boundary?
Transform.
It is a transform boundary. So right next to California, how about you write the words transform fault next to California? We know there was a transform fault in Haiti. This one also in California, transform fault. So right by the word California, write transform fault. If you don't know, or transform boundary if you want. If you don't know how to spell it, it's right here on number 2. So now we're going to look at another transform fault that's running through California. Whoops. And there was a great picture of it up there. There's the picture of the fault.
This infamous
Right
fault
through
system
here.
stretches 800 miles from Northern California to the Mexican border.
Now most of it is in the desert.
Like the fracture under Haiti,
It's not going to cause
it's a
much
vertical
damage.
strike-slip fault, meaning the plates grind past one another horizontally. But here, the plates move more than 3 times faster at over an inch a year, generating powerful earthquakes.
It's moving faster, it's going to have more earthquakes.
In the south, some sections have been quiet for over 150 years.
Sorry, we missed
Now,
number 7.
Saddle
Number 7 says how long was it? I think it was 800, is that right? Anybody? We don't remember? Let's go back.
one another horizontally. But here, the plates move more than 3 times faster at over an inch a year.
Oops, didn't go back far enough.
The plate California to the Mexican border. This infamous fault system stretches 800 miles
800 miles.
from Northern California to the Mexican border.
And it moves fast.
Like the fracture under Haiti, it's a vertical strike-slip fault, meaning the plates grind past one another horizontally.
You're striking
But
and
here,
slipping.
the plates move more than 3 times faster at over an inch a year,
Let's add that. 1 inch per
generating
year.
powerful earthquakes. In the south, some sections have been quiet for over 150 years. Now, satellites measuring ground shift reveal a buildup of stress energy equivalent to 3,000 nuclear bombs. The next rupture could be the big one. And it's the LA region that's under threat.
So the problem with San Andreas is it runs right down
Tom
through
Jordan of the
Los
Southern
Angeles.
California Earthquake Center has spent years preparing for this quake.
We have something like 800 scientists working together on a series of projects trying to really understand the earthquakes in Southern California, where we have a very complex fault system, very active, a lot of risk to the 20 million people that live here. This is
Gorgeous place to live.
We don't know when that earthquake or sequence of earthquakes will occur, but they're inevitable.
The last lethal quake on the San Andreas Fault system was the 1994 Northridge earthquake, which killed over 60 people and caused $20 billion of damage. And that was only a magnitude 6.7. Jordan and his team believe that levels of stress now indicate the rupture on the main fault could be 30 times greater. The city recently played out a worst-case scenario.
Stay with me,
We
kiddo.
had an
I'll see.
exercise, we developed a
turn the
course
light
in
on so that
California
it's not
in
kind of
2008. We call it the Great Southern California Shakeout. we created a scenario of a very large earthquake, magnitude 7.8 earthquake, on the San Andreas Fault just east of Los Angeles. And we asked the question, what would happen if that earthquake occurred?
The conclusions? Over $200 billion of damage. Millions of...
The Great American Shakeout was a practice for a large earthquake in Los Angeles. Why did they go through it? Yeah. Yeah, to prepare for the next one, to prepare. Because they want to make sure that they're not, all of a sudden it's like, what? It happened, dang, I wish we would have known that, I wish we would have known that. Y'all know about that little 6-year-old that came into the school with the gun? And now there's a lot of parents that are upset saying, well, why didn't you have, this in place beforehand? Why didn't you have that in place beforehand? A lot of times you don't know what's going to happen until it happens. So yeah, they're trying to prepare.
People displaced and thousands of deaths.
If this earthquake would have happened in reality, there would have been buildings coming down. We know that there would be no water now in certain areas. So that's what this exercise is all about.
If scientists are right, millions of people face a massive disaster.
The San Andreas Fault is very capable. You might say it's locked and loaded.
With so much at stake, some seismologists are exploring new methods of forecasting when a quake will happen. Probing deep inside the hazardous faults, they're learning to listen for clues.
A lot of good jobs out there if you want to study the earth.
Anza Borrego State Park, Southern California. This rig is drilling for something more precious than gas or oil. It's part of an ambitious attempt to find the holy grail of seismology. Underground activity that could warn of the next major earthquake. Geologist Frank Vernon is in charge.
So this is your third drill string here? Third stick. Third stick going in.
They're just a few hundred feet from the San Jacinto Fault, an active offshoot of the San Andreas system.
We actually have a lot of earthquakes occurring in here. As we said, we've had 4 magnitude 5s in the past decade. We have magnitude 4s on the average about once a year. 4 days ago, we had a magnitude 5.6, 10 kilometers over here. It's a very unique place, so this is the reason why we want to work here.
The team uses the rig to plant sensors deep into the rock, embedding them 800 feet down, shielded from surface noise. Here, as clashing plates squeeze and distort along the fault line, tiny tremors and pressure changes are produced. The sensors detect them. Any one of these signals could be the clue that a major quake is imminent.
So what they're doing is listening for tiny tremors and differences in pressure. They're trying to see, is there something that happens right before a larger earthquake? Because if there's something that happens consistently right before a larger earthquake, and you go ahead and find that moment in time, then you can send out a warning and say, hey, it's possible, we're going to get an earthquake within, I don't know, a day or an hour. Who knows?
Change in shape of the earth right underneath us in these boreholes.
We got 4 minutes.
When an earthquake happens, you will see a change in that shape. There will be slight changes that we can observe.
But identifying a specific tremor or pressure change that
They're always trying to
precedes
predict
a major
the next
quake
earthquake.
hasn't been easy. Over the last 4 years, Vernon's team has surrounded the fault with 8 borehole sensor stations. They've recorded many small earthquakes and are now sifting through a huge amount of data. The race is on to find a signal that is common to all of them.
We're a long ways from real earthquake prediction. It's not like we're going to achieve it today or tomorrow. That's quite a bit further down the road.
Though they haven't found it yet, this method of forecasting earthquakes holds promise for the future. But for now, the earthquakes keep on coming. Just weeks after Haiti, another massive quake. Chile, South America. February 27th, 2010, 3 in the morning.
This is sad because everybody's where at 3 in the morning? Sleeping in their house.
This quake reaches an incredible magnitude 8.8, the 5th largest ever recorded. Daybreak revealed.
So, February 10th, there was a massive earthquake in Chile. It was a magnitude 8.8. So that is 8.8. That is incredibly massive. It was the 5th largest ever recorded in history. All right, can somebody please on your paper write down 1955 for me so I know where to start tomorrow? If you wouldn't mind shutting that off, I'd appreciate it.